So let's study together. We are going to study the standard books together because it is my first time reading the standard books, and it may be helpful for you also. So let's start. This is the Langman third week of development. Trilaminar germ disk. Gastrulation, formation of embryonic mesoderm and endoderm. So what is gastrulation? It is formation of embryonic mesoderm and endoderm. It is called gastrulation. Okay, it is formation of mesoderm and endoderm. The most characteristic event occurring during the third week of gestation is gastrulation. So, gastrulation occurs on which time? Third week. The process thus establishes all three germ layers, ectoderm, mesoderm, and endoderm, in the embryo is called gastrulation. Gastrulation begins with formation of primitive streak on the surface of epiblast. So when gastrulation begins when forming primitive streak. It started to form. Then gastrulation begins. Initially, the streak is vaguely defined. So initially, the streak is vaguely defined, not defined clearly. But in 15 to 16 days, the embryo it is clearly visible as a narrow group with slightly bulging region on either side. So reading this, we can see that there is a streak and the both the portion of the string is bulging. The bulging region on either side. The cephalic end of the streak, the primitive node, consists of a slightly elevated area surrounding the small primitive pit. So at the cephalic end of the streak, there is a pit, small pit, or a depression, which is surrounded by primitive node. Okay. Cells of the epiblast migrate toward the primitive streak. Upon arrival in the region of streak, they become flask shaped. So upon arriving at the region of streak, they become flask shaped, detached from the epiblast and slip beneath it. This inward movement is known as invagination. So cells from the other parts of the epiblast comes to the primitive streak and they become flask shaped. They detach from the epiblast and slip beneath the primitive streak. And this inward movement of the cells, let's imagine this just like so. Other portion, there are cells on epiblast. They are coming towards this primitive streak. They are becoming flask shaped and they are going inward. And this inward movement is known as invagination. Okay. Cell migration and specification is controlled by fibroblast growth factor 8, which is synthesized by streak cells themselves. So, this migration of cells from epiblast toward the primitive streak and their movement towards downward direction or inward direction is controlled by fibroblast growth factor 8. Fibroblast growth factor 8, FGF8, which is synthesized by streak cells themselves. So, who synthesize this? Streak cells. They themselves synthesize this. This growth factor controls cell movement by down regulating E-catherine, a protein that normally binds apiblast cells together. So this growth factor acts upon E-catherine, which binds these apiblast cells together. So probably the explanation may be E-catherine, which restricts the mobility or movement of apiblast cell. This E-cadherin is down regulated by this FGF8 or fibroblast growth factor 8. So the epiblast cells can move and they get mobilized towards the perimeter streak. FGF8 can control self-specification into the mesoderm by regulating brachyury BRACHYURY expression. I don't know what is this. Once the cells have invaginated, some displace the hypoblast, creating the embryonic endoderm, and others come lie between epiblast and newly created endoderm to form mesoderm. So, once the cells have invaginated, some uh, so you can imagine that the upper portion is epiblast and below epiblast, the layer was hypoblast. So, cells from the epiblast, cells from the epiblast, somewhere in this portion there is primitive streak. So, cells from the epiblast comes, go downward, and they displace cells of hypoblast. As they displace cells of hypoblast, displacing the cells of hypoblast, they forms endoderm, and some of the cells from the epiblast comes between endoderm and upper epiblast cells, and they form mesoderm, and the remaining cells of the epiblast they then form what they then form ectoderm. Thus the epiblast through the process of gastrulation is the source of all the germ layers, and cells in these layers will have give rise to all of the tissues and organs in the embryo. Okay. Bye. So you can see we both of us can together read this kind of big standard books, and this is helpful to you and this is helpful to me also. So bye. I'm starting the series of reading line by line. I'm also reading first time, and you probably also reading the first time, because who reads these standard books? Time taking. This is a time taking really. Okay. Bye.